Ever pondered over the philosophical chasm that separates Bayesian from Frequentist statistics? It's a battle of beliefs, a contest of convictions, almost akin to the age-old debates of fate versus free will. Today we dive into these deep waters, exploring the fundamental differences and similarities between these two schools of thought in the realm of statistics. On one side of the ring we have Bayesian Statistics, named after Thomas Bayes, a statistician who believed in the power of prior knowledge. Bayesians argue that statistics is about updating our beliefs in the light of new data. They start with a hypothesis about the world, and then adjust this belief as more data pours in. The key here is that Bayesian statistics incorporates subjectivity, allowing for individual interpretation. Now, stepping into the ring from the other corner, we have Frequentist Statistics, the brainchild of Ronald A. Fisher. Frequentists view the world differently. They argue that statistics is about long-term frequencies. They believe in the power of repeatable experiments, and they reject the notion of prior belief. For them, data speaks for itself, independent of any subjective interpretation. But wait, the Frequentists counter the Bayesian approach, arguing that it's too subjective. They question, how can we trust the prior? Isn't it just a guess? They contend that the Bayesian method is prone to bias, since it allows for personal beliefs to shape the interpretation of data. Yet the Bayesians aren't without their retorts. They challenge the Frequentists' reliance on repeatable experiments. They ask, what if we can't repeat the experiment? What if we only have a single shot to make a decision, like in medical diagnoses or climate change predictions? Isn't it then more sensible to incorporate prior knowledge, however subjective it might be? Despite these differences, let's remember that Bayesian and Frequentist statistics also share common ground. Both approaches aim to make sense of the world around us using data. Both offer tools to test hypotheses and make predictions. Both strive to turn raw numbers into meaningful insights. But perhaps the most profound similarity is the recognition that neither approach is inherently superior. Each has its strengths and weaknesses, and the best choice often depends on the specific context. Some situations call for the subjectivity and flexibility of Bayesian statistics, while others demand the objectivity and rigidity of Frequentist statistics. So we've journeyed through the philosophical landscapes of Bayesian and Frequentist statistics, witnessing their clashes and concurrences. We've seen how Bayesians embrace subjectivity, adjusting their beliefs in light of new data. And we've observed how Frequentists champion objectivity, trusting in the power of repeatable experiments. Yet at the end of the day, both Bayesians and Frequentists are united by a common goal: to make sense of this complex world through the lens of data. And isn't that what statistics in all its forms is truly about?